So you just did a Desmos activity of a real world situation where you use function notation to express certain features about the situation, such as how high a man was when he was shot out of a cannon, or the height of a Ferris wheel cart over a certain amount of time. And so function notation is very powerful because it allows us to give in general the general rule or the general structure of any situation. So you might see something in general like this where there's no numbers. And it also allows us to give very specific information such as f of 2 equals 5, gives you a specific point on the function. So function notation is super powerful because it can tell you abstractly how do you find the y value for any x value that you're given, and it can tell you precisely one exact point. And the powerfulness comes from the notation using the same exact notation for both of those concepts, for the general idea of a certain situation and for a very specific point modeling the same situation. That's very powerful. Okay, so in this quick video, we're just going to do two examples to drive home the idea of what function notation means. So as a reminder, this should be fully internalized into your head. If not now, then for sure within about a week. Y equals f of x, and the way we read that is y is a function of x. This idea here, this means that x is the independent variable. So this is the independent variable, or the input variable, or input. We call them both. We call x both of those terms, so they're like synonyms. And y is the dependent variable, or the output. Those are also, we use them interchangeably in the mathematical world. So that's really important. This idea that y is a function of x, it means the same thing if I said y depends on x. That's what that means. These two phrases, they mean the same thing. It means that if I tell you an x value, there should be exactly one y value. How do I know that? Because that's the definition of a function. So all of your knowledge should start to get fully rounded out now. So let's look at these two examples. We'll do this one first. The value of your car is a function of the number of miles driven. Explain the meaning of f of 52,000. So why don't you pause your video now and try this problem. Okay, so what you're looking for to kind of break down what's happening in any of these word problems is you're looking for this phrase, is a function of, or you're looking for the phrase, depends on. So the value of your car is a function of. That means the value is means equals. When you translate this into math, that's the same thing as equals. A function of, that translates to f parentheses, f of, so the value of your car is a function of, and then whatever comes after that, the number of miles. So inside here, we're going to put number of miles. And there you go. And the reason why that type of strategy is so important is because it allows you to see which variable is the independent variable, which is this one, and which one is the dependent variable, which is that one. So here I can show you that the independent, or the input, you could call it the same thing. Input is the number of miles driven. The output is the value of your car. Now that we've done that work, now we can interpret f of 52,000. So what does this mean? This means the 52,000 represents the number of miles because it's on the inside of the parentheses. It represents the input. So the input goes inside the parentheses. The independent variable goes inside the parentheses. So all of these things that start with I, they are all the x value. So inside, input, independent, all of those things, they're the x variable. Okay, and then f of that equals a y variable. So I'm going to just put notes here. This equals y. Like, we don't know what it is because you're not given it in this problem, but we know what y stands for. It stands for the value. So this is the same thing as y. This over here is the same thing as x. X is the input. Y is the output, or the value of your car in this case. So what does this whole thing mean? Let's put that in another color. F of 52,000 means, F of 52,000 means the value of your car if it has 52,000 miles on it. Now, we don't know what the value is because it doesn't say that it equals a specific number. But if it did, like, I can tell you the value of my car when it had 52,000 miles was about $24,000. So that would say equals 24,000, something like that. Of course, you know my car is the greatest car in the world. It is a Subaru WRX. If you don't have one, join the Subi Club. Go get yourself one. If you can't get one, just get like a little model of it, right? And then just take a picture, send it to me. I'll be super impressed. Okay. So here's that whole interpretation of what this thing means. And you can see we wrote a lot here because it's involved this little tiny notation here, like there's not a lot written there, means a mouthful. It means a lot. Let's look at example 2. Let's try this one. This says, the cost of a cup of tea is a function of the size in ounces of the cup. Interpret G of 12 equals 4. So interpret what that means, assuming that G is the name of the function. So pause your video and try this problem now. What does that whole sentence mean? Okay, so again, I'm going to do the same type of analysis that I did up here. I'm going to translate this English that I see into math. So here's the key phrase, is a function of. This means whatever came before that equals, and then right here, this is f of, and then whatever comes after that goes in parentheses. So let's write all of that right here. Let me move this down so you can see. So the cost is, that means equals, a function of f of the size. So now you can quickly see, that's why that's so important to do that front-loaded work before you try and even understand what this means. Now I see that the input, let's do the input first, which is the same thing as x, is the size. It's also what's inside parentheses. And then the output, which is also the y value, is the cost. Now that we know that, we can interpret what this means because I can see here's the x value. It's always what's inside. This is g of x equals y. So the x value is 12, the y value is 4. Another way of saying that is the independent value is 12, the dependent value is 4. Or the input value is 12, the output value is 4. Which means this represents 12 ounces. That's the size that you bought. And this must represent $4 because the dependent variable in this situation is the cost. So what does this mean in simple English? As simple as you could describe, it means a 12-ounce cup of tea costs $4. That's what that means. And that's putting it in a very simple way with no X and Y's, no mathematical terminology. We're trying to explain that to, a fifth grader, somebody who hasn't seen any, well, I don't know what they're doing in fifth grade now, but explain it to somebody who hasn't seen any kind of variables or mathematics, who would get overwhelmed if you started talking with letters. Okay, all right, so now you should have a pretty good idea of what functions mean. You should know what functions look like graphically. You should be able to read a function of tables and understand the input and the output and what's going on if it were modeling a real-world situation. And you should understand how to look at function notation abstractly, which means without a real-world context like this. And you should be able to find things like f of 4 or f of x if, or you should be able to find x if f of x equals 10 or something like that. So you should have a pretty good arsenal of skills in your toolbox now, all related to functions. After this unit, we're going to move on and we're going to talk about specific functions that are given names because they come up in real life so often. So we are going to cover linear functions and exponential functions. There are lots of other functions out there, so you might see quadratic functions, or you might have already seen trigonometric functions like sine and cosine. Oh my goodness. We're not going to cover any of those in this class, but it is important to know that some functions come up so often that they have names that we apply to them. And so we're going to study some of them in this class after this unit.